Okay, let's cover Rook combinatorics. Let's look at a two-dimensional board where the coordinates are where A is 1 and H is 8. The valid move of a rook is either vertical or horizontal. That means if the starting position is x1, y1, it can move to x2, y1 or x1, y2. The starting position of a rook is x1, y1. It will either move to x2, y2, x2, y1 or x1, y2. Either it will change the x component or the y component. Here x1 will be a to h and y1 will be 1 to 8, and so is x2, where x2 is not equal to x1 and y2 is not equal to y1. Now a rook, after walking on a board, one of the four possibilities will happen. Star x1, y1. It starts from x1, y1 and it reaches x1, y2. x1, y1 and it reaches x2, y1. From x1, y1 it reaches x2, y2 and last x1, y1 to x1, y1. So here are the four possible outcomes. The rook in the end changes the x component either and does not, and the y it changes the y component and the x component remains same, either, or it changes the x component and the y component does not change, or both x component and y component changes, and last, neither x component nor the y component changes. So these are the four possible outcomes. So one can club this into three. Either both row and column are different, only one of row or column is different, both row and column are same. Now this is for start and positions of rook. Now one assume R1 the R1 of n as both different, R2 of n only exactly one different, R3 add to same square, closed walk. So let R1 be, R1 of n be number of ways the rook can move from the starting, where the starting position and the ending position have different row and column. R2 as where either the rows are same or the columns are same, not both. And R3 as both row and column are same, meaning you start and end at the same place. So the R1 of n for a so in the first move it will become, say, alpha comma y1 and beta comma y2. Okay, so alpha is not x1 and beta is not y1. Okay. So alpha has possibilities of, okay, it has 6 possibilities. Either, so it's 1, 2, so case 1 when alpha is not x2, 1 to 8 minus x1 x2, which is 6 elements. And take the other case when beta is not equal to y2. Then beta you have 1 to 8 except y1 and y2. Also you have 6 possibilities. So you have R1 of n as 6 R1 n minus 1 plus 6 R1 n minus 1 plus 2 R2 n minus 1. Because from after making one move from x1 comma y1, it will move to alpha comma y1 or x1 comma beta. These are the two possible ways where alpha is anywhere between where alpha is not x2 and beta is not, where alpha is not x1 and beta is not y1. So alpha, if alpha takes any of the 6, then it's 6 of r1 n minus 1, and if beta is not y2, then it's also 6 r1 n minus 1. If alpha is so there are 14 possible ways. Alpha has 7 possible outcomes, beta has 7 possible outcomes, but out of 6 they fall in the R1 category, and for alpha, and 6 for the beta, and the 2 are adjacent to x2 comma y2. So if alpha is x2, then it falls under the R2. So x2 comma y2, x2 comma y1, 2, x2 comma y2, it takes R2 of n moves. So here R2 of n minus 1, since one move is already taken, and for x2 for x1 comma y2 to x2 comma y2, it takes again R2 of n minus 1, since there are only n minus 1 moves left. And for alpha not equal to x1 x2, you have alpha comma y2 to x2 comma y2 taking r1 n minus 1 moves. And same with beta not equal to y2, x1 comma beta 2 x2 comma y2 taking r1 n minus 1 moves. So we get the following for R1, that R1 is 12, R1 of n is 12 R1 n minus 1 plus 2 times R2 n minus 1. And what about R2? Well, from x1 comma y2 to x2 comma y2, the possible moves are alpha comma y2 to x1 comma beta, where alpha is not x2 and beta is not y2. In this case, there are there are 6 possible, 6 plus 1, 1. Well, if alpha is x2, then it reaches the destination. If alpha is not x2, then there are 6 possible outcomes, 6 possible choices for alpha. And for beta, there are 7 possible choices. So, what do you get? You get 7 R1 n minus 1 plus 6 R2 n minus 1 plus R3 n minus 1. Because after changing x1 y2 to x1 beta, then, and since beta is not y2, it takes r1 n minus 1 moves to reach from x1 beta to x2 y2. And for alpha, there are 6 choices provided, 6 choices for alpha where it does not reach x2 y2. So for alpha y2 to x2 y2, it has r2 n minus 1 choices times 6. Since there are 6 options, 6 such alpha where this is possible. So 6 r2 n minus 1. And for x2 y2 to come back to the original square, it must have, there are r3 n minus 1 possible ways. So you have the following. Since there are 14 choices, alpha has 7 choices, beta has 7 choices, so total 14 choices, 14 different moves from x1 y2. So you get the following recursive relation. And R3 of n, well, to find R3 of n as a recursive relation, you start from x2 y2 and you want to reach x2 y2. Well, from x2 y2, it can reach alpha y2 or x2 beta, where alpha is not x2 and beta is not y2. So alpha and beta have 7 choices and there are r2 n minus 1 ways to reach. There are r2 n minus 1 ways for the rook to reach x2 y2 from alpha y2, alpha comma y2, and x2 beta to x2 y2, it takes r2 n minus 1. So therefore there are 14 such choices. So r3 of n is nothing but 14 times r2 n minus 1. So you have the equations. R1, R2, R3 of n is nothing but 12, 2, 0, 7, 6, 1, 14, 0, 0, R1, R2, R3 of n minus 1. Well, R1 is 12. R1 of n is 12. R1 n minus 1 plus 2 times R2 n minus 1 plus 0 times R3 n minus 1. R2 of n is 7 times R1 n minus 1 plus 6 R2 n minus 1 plus R3 n minus 1. And R3 of n is 14 times R2 of n minus 1. So you get the following matrix relation. One can compute this matrix relation. One can diagonalize this matrix. Also, by recursion, one gets this. R1 of 0 is 0, R2 of 0 is 0, R3 of 0 is 1. So you get the following. R1 of 0 is 0, since it's not possible from x1 y1 to reach x2 y2 in 0 moves, but it's possible to reach x2 y2 starting from x2 y2 in 0 moves. So R1 of 0 is also same as R1 of 1, which is also 0. R2 of 1 is 1. R2 of 0 is 0. R3 of 0 is 0. But R3 of 1 is 1, since it must move out of x2 y2. So therefore I'll explain this. So from x2 y2 it must move to alpha y2 or x2 beta, which means that it's not possible to go and come back in a single move. Since not moving does not count as a move, therefore R3 of 1 is 0. R3 of 0 is 1. Correction. Computing this matrix relation will give you the value of the number of ways a rook can move in an 8x8.